So we are on our fourth and final little piece. This one should be fairly short. I just want to talk about serous membranes. Okay, very serious. Serous membranes. Okay, so lining your organs and lining the walls of your organs, the walls of the cavities are serous membranes. And those serous membranes secrete a fluid that's called serous fluid. And the function of that serous fluid is to create a little bit of lubricant so that you have less friction. So for example, lining the outside of the heart is a membrane called the visceral pericardium. And then lining the cavity surrounding it, the pericardial sac surrounding it, would be the parietal pericardium. Okay, so notice that they're paired. There's two of them. You have one that's called visceral, that closely lines the organ itself. And what I mean by that is it's stuck right on the outside of that organ. And then you have the parietal one, which is going to line the cavity that surrounds it. Usually it's like the body wall. Okay, so you have two membranes. Both of them are secreting serous fluid. And so that as they move, the organ moves, they're going to have less friction and they're not going to rub against each other. Okay, so think about that heart. Right, so that heart, usually they beat about 70 beats per minute, so 70 contractions every minute. Every minute, they're just moving around. Now, if you didn't have any serous fluid in there, you're going to get a lot of friction, and friction can be damaging. So you want to make sure that you have a nice lubricated kind of slippery surface so that as the heart is contracting, it's going to move smoothly around itself so that it doesn't rub away at any of the organs, any of the lungs or any place else, and it has a nice reduced friction. Okay, so the function of all the serous membranes is to reduce friction. That's the main point. It doesn't matter which serous membrane I ask you, answer is always the same. Reduce friction. Okay, so now let's go into some of the specific serous membranes. Let's start with the one on the heart because I kind of already mentioned it. So when you look, if you were to open up a cadaver, this is what you would see. You wouldn't see anything that looks particularly, distinctive in there. It just kind of looks like big blobs. And the reason for that is because the heart is contained inside of its little cavity. So you have a tough fibrous membrane that creates the pericardial cavity. So that's called the pericardial sac. So if you were to cut the pericardial sac open and kind of reflect it backwards, this is what you would see next. So here is the heart, and you can kind of even start to see some of the cardiac muscle on there. Kind of looks like steak there. Lining the outside, you kind of see how it's a little bit shiny on the outside of the heart. Muscle is not shiny. The reason it's shiny is because it has a membrane on it, and that's called the visceral pericardium. So remember, visceral means stuck on the organ itself, like part of the organ itself. And peri means around, cardia means heart. So the membrane on the heart is the visceral pericardium. And then lining the inside surface of the pericardial sac that you just reflected backwards, that would be the parietal pericardium. Parietal means lining the cavity, and then pericardium again around the heart. Okay, so again, they're paired. Visceral on the organ, parietal on the cavity. Okay, next one would be the pleural. Pleural. What did pleural mean again? Do you remember? Pleural means lungs. Lungs. Okay, so here, what we're looking at in this one is a cat. Okay, so you cut open the cat, you reflect it backwards. Here's the heart right there. So these structures right here, these are lobes of the lungs. And if you look at the outside of the lungs, again, they've got that nice shiny little texture on the outside. That is the visceral pleura. The visceral pleura is the shiny membrane lining the outside surface of the lungs. And then lining the rib cage, so the cavity wall, that would be the parietal pleura. parietal cavity wall, pleural lungs. So that creates the shiny membrane that kind of lines the cavity itself. So on the rib cage there. Okay, down into the abdominal pelvic cavity, the serous membrane in the abdominal cavity is called the peritoneum. Okay, so again, there's going to be they're going to be paired. You have the visceral peritoneum, that's going to be on the organ itself. For example, the small intestine surrounding the outside. So if you have the small intestine, you cut through it. Along the outside of the small intestine, there's the tube of the small intestine. There is the visceral peritoneum here. And then the pair for that would be the parietal peritoneum. And the parietal peritoneum is going to be lining the inside of the cavity wall. So the way to think about this is if you were to cut the cadaver open and look at the inside of the muscles, right? So you take those abdominal muscles, pull them back, lining the inside of those abdominal muscles, that's where you would find the parietal peritoneum. And again, both of them are secreting that serous fluid so that as you're moving around, your organs are sliding all neat past each other. So visceral peritoneum on the organ, parietal peritoneum on the cavity body wall. We also have, oh, this is what it looks like. So there's your small intestine, there's your parietal peritoneum. We also have a couple of special ones that we need to talk about, okay? Oh, sorry, I forgot I added this. Sorry, back up, beep, beep, beep. Okay, I wanted to mention one more thing. Okay, so here is here is your parietal peritoneum. See that? It's that lining right there. So skin, muscle, parietal peritoneum here, visceral peritoneum lining the organs itself. Okay, one thing I wanted to point out, and this is just for future reference because we're trying to talk about kidneys later. Kidneys are what we call retroperitoneal. Retro means behind. Okay, so retro means behind, and so all we really mean is that the kidneys are not going to be included in that cavity. The kidneys are behind it because they're going to be underneath the underneath that visceral, sorry, I keep saying the wrong words, underneath the parietal peritoneum. Okay, so there is the parietal peritoneum, kidneys underneath, not inside of this area here. Okay, they are retroperitoneal. Okay, now we're going on to some specialized membranes. Okay, there's two that we're going to talk about. The first is called the greater omentum. The greater omentum. So if we're looking at this picture here, there's the diaphragm, there's your liver, there's your stomach. On the edge of your stomach, it's called the greater curvature of the stomach, you have this apron of membrane that droops down and kind of comes back up. So you can literally flap it up like wearing an apron, okay? And the function of this greater omentum is that it's absolutely packed with a whole bunch of fat, okay? So why would you want an apron of fat covering your intestines? Think about it. Are there bones in your abdominal cavity? Nope. So the rib cage, right? The thoracic cavity's got all these hard bones protecting those organs. What's protecting the abdominal pelvic cavity? Fat, mostly. Okay? So you have this apron of fat right here because it's going to drape over all of those intestines and protect them, give it a little bit of shock absorption, make sure that you keep them nice and protected. So you have thermal and you have shock protection for those organs. Okay? So those are going to be very important for protecting those organs. And again, it's just an apron. If you open up a cat, you can literally just flap it up. It just lays over the top of it. Okay, second one. The second specialized membrane that you need to know about is called the mesentery, or sometimes referred to as the mesentery proper. Okay, so when we're looking at here, so here is the greater omentum flopping over just the front, just anteriorly. Behind it, posterior to all of that, is going to be the mesentery. So if we look at these circles here, these circles are representing the small intestine. So if you open your cat and you pull the small intestine outward, what you would see is that it is anchored to the back wall. So if you were to slice open your stomach, your guts aren't going to just spill out. And the reason for that is because they're physically anchored to the back wall. So the function of the mesentery is to anchor the intestines to the posterior wall of the abdominal cavity. Okay, so this mesentery here, it's a clear membrane, and then running through that clear membrane is a bunch of blood vessels. The yellow ones that you see are part of what's called the hepatic portal system. And basically what they do is they take nutrient-rich blood, so nutrients that just came out of the small intestines, and take them up to the liver so that they can be stored and filtered there. Okay, so main function of that mesentery is to anchor the small intestine to the posterior body wall. Okay, that's the mesentery. Whew. So what did we learn today? I feel like I'm talking forever. What did we learn today? Talked about organization, a hierarchy, going all the way from atoms to cells to organ systems and onward. We talked about regional and directional terms. Make sure you practice those. I know it feels tedious now, but you will thank me when we get to the bones. I promise you that. We talked about body cavities, and make sure you have them nice and organized for yourself, and you can say some organs that are found in each one. And then we talked about those serous membranes, and remember the two special ones are the greater omentum and the mesentery. Okay, so it's a lot. So make sure that you practice those, and what I would like you to do is, while it's still fresh in your mind, go to week 1 module and go ahead and take that mini quiz. That mini quiz is designed as practice to review all the material that we just talked about right now. If you that quiz can be taken as many times as you want to, so you can take it for practice, or you could just keep taking it until you get all the points correct. Bye. Nice to see you.